All right, welcome to lesson 13 concept development video. I tried to be as spooky as possible in my writing with my letters and numbers for this lesson. I hope you can see that, very in the spirit of the fall and Halloween. Today we're going to be dividing decimals and we're going to be using the decomposing of our numbers into smaller units in unit form to easy to use multiples to help our brains. So once again, it's very important for us to know our multiplication facts and our multiples so that we can easily use unit form to simplify the math. So without further ado, let's get into some math problems where we're dividing our decimals. So let's go ahead and start with 9/10. So 0.9. And we're going to divide this by 3. So let's just convert this and use a place value chart for the first. I shouldn't have said convert, but let's place this into a place value chart. Ones and tens and tenths, hundreds, thousands, right? So if I put, I'm going to use disk this time, 9 disk inside of our place value chart, and I wanted to make 3 equal groups, I would have 1 group down here, 2 group, and then 3 groups. So now I've represented 1 group, 2 group, 3 groups on my place value chart to pass these out. And I could just go 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I know I've used all 9 of my number discs up here and passed them out evenly to those 3 groups. So I know that 9/10 divided by 3 is going to be 3/10. Okay, so let's just do that again with the place value chart for another number. And this time, we're going to do 24 hundredths. And we're going to divide that by 4. Again, let's go ahead and use the place value chart to start our brains. And we want to label our place value chart really quickly. And then we're going to go ahead and represent 24 hundredths. So it would be 2/10 and 4 hundredths, right? And we're going to represent that with, we're going to divide that into 4 equal groups. So there's 1 group, 2 groups, 3 groups, and 4. 1, 2, 3, and 4. So I now have 4 groups to regroup to. Oops, sorry. I accidentally clicked the wrong button. And now we're going to regroup these. So, well, I can 1, 2, 3, 4. I've shared all of my hundredths, right? But I don't have enough tenths to share equally, so I need to convert those and decompose them back into here. So I know that that's going to give me 2/10 is going to give me 20 hundredths. Oh man, look at it. It's already getting really sloppy in here and hard to see. But I know that's 20 dots, so I can just start dividing and passing out or distributing all those words of work to our 4 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Wait, I only needed 20. Let me back up 2 of them right there. So how many are equally in each group? Well, let's count into each group. 1, 2, 3, 4, 5, 6. I see 6 of them in each of them, and it's in the hundredths place. So I know 24 hundredths divided by 4 is going to be 6 hundredths. Well, that is not the most efficient way to solve our division problems. It definitely works, but as you can see, when we start regrouping and getting large numbers inside of one place, and then all those number disks gets very difficult to work with. So let's try using the method where we were decomposing into smaller units So let's try it with 1.5, and we're going to divide that by 3. Oops, I'm sorry, we're going to divide that by 5. So what is that going to equal? Well, let's convert it into unit form and to the smallest unit. Well, on this one, we could say 1 and 5/10 really is 15/10. And we divide that by 5. Well, that should be a math problem that we know. Or if you can't think of division facts, well, what times 5 gives you 15? Think of it backwards, because division is just the opposite of multiplication. So, well, if we count by 5s, 5, 10, 15, we know there's 3 groups of 5 inside of 15. Well, the unit has to come with us because nothing changed to the unit. So 15/10 divided by 5, or 15/10 put into 5 equal groups, is 3/10. Well, 3/10 converted back to standard form is going to look like 0.3. I prefer this method over the place value chart all day long. So let's try this again. Let's try it again with one where it's not as easy just to convert into the smallest unit. So what I mean by that is 1.05, or 1 and 5/100. And this time we're going to divide it by 5 again. Okay. Well, if I just converted it into the smallest unit, it would be 105/100 divided by 5. Well, my brain doesn't know how to do that like simply and quickly. So let's get rid of that and let's think of a different way to decompose it. Is there a different way to decompose it? Could we decompose it into 2 different units? Could we decompose it into tenths and then hundredths? As I'm writing this number down, I want you to think about, why would I convert it into tenths and decompose it to tenths and hundredths while I'm dividing by 5? Well, this answer for that is, do you see that they're easy multiples of 5? Well, 10/10 divided by 5 would give us 2/10. And 5/100 divided by 5 would give us 1/100. So the answer would be 0.21. Ooh, I love unit form because it makes our brains simplify the math into simple multiplication or division facts. 10 divided by 5 is 2. 5 divided by 5 is 1. And then we just use our unit knowledge and the unit place value knowledge to put it back into standard form. Let's try that again. This time I'm not going to help you decide where to decompose to, but I'll give you a hint. You're going to want to decompose this number into 2 different units. So 3 and 15 thousandths. And we're going to divide this again by 5. So look in the number for multiples of 5. Do you see a multiple of 5 and 30? And then do you see a multiple of 5 and 15? Because I do. So let's convert there. Well, that would be in the tenths, 30 tenths. And then the next part would be 15, well, thousandths. So, whoops, thousandths. Now we've converted, but we're dividing both of these by 5. So we're dividing the 30 tenths by 5. And then we're dividing the 15 thousandths by 5. So when we're thinking about this, if you're struggling with division, think about it backwards. What times 5 gives you 30? Well, 30 divided into 5 equal groups is 6. Or if you were thinking about backwards, 6. Whoa, Mr. Biggs. What just happened there? There it is. 6 tenths because our unit stays the same. And 15 divided by 5. So 15 divided by 5 would be 3, right? Because 3 times 5 equals 15. Well, our unit stays the same. So 3 and 15 thousandths is 6 tenths and 3 thousandths. So it would look like 5 or 0.603, and that is perfect. So let's try a few more. And then we'll go on to our problem set. Okay, so let's try 63 and 21 thousandths. We're going to divide it by a digit that's a little bit more challenging than 5. So let's divide by 7. Let's have our dividend be 7. So we need to know our multiples of 7. So 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. Well, as I was saying those multiples, I saw the 63 and then I saw a 21. Notice I did circle the 0 with it. I want all digits to be decomposed into a unit. So we can't leave anything out. So we have 63, and that's in the last digit is in the ones place of that number. So we have 63 ones, and then we have 21 thousandths, right? Both of those numbers are multiples, are multiples of 7. So when we go to divide these by 7, I'm thinking of my multiples of 7. Well, I know 63 divided by 7 is 9. So it's 9 ones. And then 21 thousandths divided by 7, I know is 3. So it's 3 thousandths. So I know the answer to this math problem of 63 and 21 thousandths without setting it up long division, without just seeing the multiples in there. I can just do it really quickly. And I know that the answer is 9 ones and 3 thousandths. Now, this is not going to work all the time. We're going to have remainders coming in the next couple lessons. So let's go on to the problem set, work on that together, and then we can do the exit ticket, and let's get ready for remainders in the next few lessons. All right, great job.